Hi everyone. Um, Let me share my screen. Today we are going to see how we can bring all the production data to our data warehouse and build a efficient BI reports. So, so this is our agenda. So initially we are going to see some terminologies like data warehousing and OLAP and OLTP. Then we are going to see a medallion architecture. And also we are going to see fact and dimension table and also few data modeling and also what we implemented for this webinar, so that end-to-end architecture. And also we are going to review all the practical steps. So let's get started. So, yeah. So short intro about the data warehousing. So this is like who all are completely new for this data warehousing terminology. So like basically, we are bringing all the production data to one centralized repository. So, like in organization, like multiple departments will be there, right? So, for all the HRMS and sales, and for all the departments, we have a separate database. So, for building a efficient BI report, so we are bringing all the department data to a one centralized repository. So that we are calling a data warehouse. And even we can retain all the historical data as well in the data warehouse. So this is about the data warehouse terminology. And also we have two more terminologies, the OLTP and OLAP. So basically, the OLTP stands for online transaction processing. So it's a production database. Like we can consider this as a production database, like where we can run all our insert, update, delete queries more efficiently. For example, like you can, yeah, if like if I order if I placed some of the orders, so that will be processed and stored in production DP, right? So that we are calling as a online transaction processing service. And similarly, the OLAP, the online analytical processing. So it's for like whatever the transactions has been processed and stored in the production DB. Like now I want to know like how many transactions has been placed and how many of the transactions has been cancelled, for what reason those transactions are cancelled. So for analyze these all business transactions, so I required the OLAP service. So basically, the OLAP services is a data warehouse. So just these two terminologies. So then, then the Medallion architecture. So actually, by using this Medallion architecture, we can break our data warehouse into a layers like bronze layer and silver layer and gold layer. So basically, a bronze layer, like we are bringing all your production data in the as it is in the same format. Like if you have some duplicate data or if you have any unstructured format data, so all we will bring it to a bronze layer as it is. Then we will process that if based on our data sets, like if we have any duplication or if any have any unstructured data, so we need to deduplicate and we need to make it to a structured data. Then we will push those data to a silver layer. So basically, we are performing a data cleaning, high level we can tell in a silver layer. Then we will aggregate those cleaned data and we will store it into a gold layer in a fact and dimension table. Like we can tell this goal layer data as a processed data or purest form of data. So in the top of the goal layer, we can build a AI layer, or so AI can read our data and can answer for all our queries. And also we can build a efficient BI reporting. The reason all the calculation is already done on the goal layer, so we are not putting any load on the BI layer. So this is the benefits of the Medallion architecture. So let's go to the fact and dimension table. So basically, a fact table, it's like in the fact table, we are storing all the business transactions. Uh, Meanwhile, in the dimension table, we are storing the description of each transactions. So for example, we can take Geopits. So Geopits is basically a data service providing company. So let's assume like I'm the client and I initiated a quote to build a data warehouse for my production database. So once everything is goes done, then I initiated my payment. So for example, um, so so for example, like um, I done my payment, so that will be stored on a fact payment table. So I'm Aravind is the one initiated this payment. So that will be stored on company dimension table. So like for what service I done my payment. So that will be available on the dimension service table, and like at what time or what date I initiated the payment. So that will be stored on a date dimension table. So basically, this is about a fact and dimension table. Let's go back to the slide. So the same thing, whatever I explained in a simple manner, the same thing I added in my slides as well. So let's go to a next slide. So the star schema and snowflake schema. So basically, these are the two types of data modeling. So under the star schema, like we can tell like whatever the dimension table we are creating for a fact table. So that particular fact table having the direct reference from all of the dimension tables. But in the snowflake schema, it's something like if there will be a chance like for our dimension table have a sub branches. So that sub branches of dimension table, we don't have any direct relation between the fact table. I think, yeah, we can use the same example. Just go back to the same whiteboard. So, see, um, this will be a great example for a star schema. You see here, whatever the dimension table I created for this particular fact table, it having the direct reference keys. So similarly, like the same fact payment table, and company dimension table, and service dimension table, and date dimension table. So here the payment is done by a client, Aravind, for what service? For a data engineering service, and he initiated today morning. So these information we will get it from the dimension date table and a dimension service table and a dimension client table. Similarly, now I want to know which person from Geopits provided this data engineering service. So for that, I creating a one more dimension table, that's a dimension employee, so by using this particular dimension table, we can get a details like who done this particular service. But here one another blocker, like maybe we can assume like Paramesh is the one done this data engineering service, and also Adnan is also included on this engagement, and from CSM, Lakshmi is also involved on this engagement. Then I want to know like all three peoples are worked technically or like what they have done. So for that purpose, like I creating a one more dimension table. Like it's a dimension department table. So by using this particular dimension table, I can get to know like who done what service. Like Paramesh is the one done the data engineering service, and Adnan is one take care of all the sales things, and Lakshmi is the one take care of all the CSM related things. So if you see here, this particular fact payment table don't have a direct relation to this particular dimension department table. So if you want a relation, we can only get it by using a dimension employee table. So like this is a Snowflake schema model. Like we have a subdivisions of the dimension table. So it is created for a complex data set. Yep. So these are the major differences between the star schema and the Snowflake schema. So based on our data set, we need to choose a data modeling. So let's go to a let's go to a end-to-end architecture, like what we have done. So just like I downloaded a OList data set from the Kaggle, and I imported the same data set on my local MySQL. So this we need to consider as a production DB, and here I using a Python as my ingestion tool. So in your requirement, like what's your production DB? Based on that, we need to choose a ingestion tool. Like if it's your production DB is a RDS, then we need to choose a snaps or a data pipeline. If it's your production DB is a POS, then we need to choose a ADF. If it's your production DB is a GCP managed DB, then we need to choose a data fusion. So based on your DB in production DB environment, we need to choose a ingestion tool. So this is a webinar. So for that purpose, I just using a open source ingestion tool. So that's a Python. So like I will bring all the source MySQL data to a PostgreSQL. It's a local PostgreSQL bronze layer schema. So I will bring all the MySQL data to a PostgreSQL in the as it is in the same format. Then so as I mentioned, the silver layer cleaning based on our data set we need to perform. So in my data set, we don't have any duplicates. So here we no need to perform any deduplication. So instead, like whatever the columns we have in the text and character data type, so there we need to avoid the unwanted spaces so that we can build a, efficient conditions and a filter on the BI report. So for that purpose, I just used a trim to remove all the unwanted spaces on all the text and the character data types field. Then I used the same PostgreSQL SQL script to aggregate those data and build the fact and dimension table in the gold layer schema in the PostgreSQL and bring all the data from the silver layer to gold layer. And then I build a, BI report. So it's a Apache superset. So it's an open source BI. So we can use it this as a very it's a freely we can use. So I just build a two reports. So it's the same reports I built. So one is sources directly coming from a gold layer, and another the same report. I used the sources coming from a MySQL, the production data, like whatever we imported from the open source. So we are using the data as it is, and we are performing all the calculation directly on the BI report. And another, the same report, we already done all the aggregation and stored in the gold layer. So we are just showcasing those data on the BI report. So let's see the report. So I installed Superset in Docker. Docker. Yeah. Just a minute. Showing my terminal. think search is not working. Just a um, just a minute. It's my bad. It's not opening. It is not showing the tab. Just think we don't have any shortcuts for this. Right. Oh, just give me a minute. Mm, Showing my terminal. It's like for oh, when it's not showing my workbench also. Okay. Let me show you the production DB first. Think later we can see the reports. It's my local. So this is a particular database, like whatever I imported from the uh, Kaggle dataset. So I just create a table and imported the data as it is in the same format. And let me find the PostgreSQL here itself. Faced such issues before. Let's see. Usually the PG admin will be slow in the Mac. So the bronze layer data is available on our local PostgreSQL. Let me open it. So these are the schemas. So bronze schema. So like in this particular schema, we bring the MySQL data in the as it is in the same format by using a Python script. Then like you see the tables, it will be available. Yeah. So we bring the tables data as it is in the same format. And this is a particular silver layer. So we performed a cleaning and we will bring the data from the bronze layer to silver layer. Then if you see the gold layer, so we build the fact table and the dimension table for this whole list data set. So these are our fact and the dimension table. Then I used the same SQL script to bring the data from silver layer to this particular gold layer. So I need to open my terminal for run the superset container. Just a minute. Search for is not open. Just a minute. Let me check. Just a minute. Let's check, is there any shortcut to, yeah, something has happened on my Mac so that it's not showing any apps on the search bar. Don't yeah, terminal. Even now. This is not on. Think just a minute. I will rejoin the call. Like I think I need to restart my system for run my superset containers. So just a minute. I will rejoin the call. Hey guys, back. Let me share my screen. So let me start run the containers. Yeah, it started running. Let's go back to the browser and the localhost. So this particular, like I just built a sales performance BI report. So this particular BI report data is directly coming from goal layer, the PostgreSQL, and also if you see this particular report, um, I bring the data from MySQL. And if you see the total revenue, that calculation here is still running. and even let me show you that particular chart. So this particular data we are getting from the PostgreSQL Go layer. And if you see this particular BI report, we are getting the data from MySQL. It's the source data, the production data. So we done all the calculation on the BI layer. So that is the reason it is still calculated and we are getting a timeout. The reason we can't able to calculate that much on the BI layer. If you see the charts, you can able to understand. So if you see here, showing no space left on the device, so it can't able to calculate the data and show the visualization. But if you see the data is coming from a goal layer, so we can get the visualization. So, so yeah, this is the reason like we need to organize our data on the warehouse based on the Medallion architecture. Instead of if we use the direct the production data, then we will get the slowness. Yep. Uh, so we done all our review process. So whatever the code we used here for the ingestion and for performing the data cleaning in the silver layer and for aggregating and storing the data in the fact and dimension table. So all the codes we will share our GitHub. So later the webinar. So do you have any queries? Do you people have any queries? Think okay, no queries. I think we can go to wind up. Yep. Uh, yeah, with you.
Yeah. Thank you, too. Yeah, well, thank you, Aravind. Yeah. We'll, as said by Aravind, we'll share all the resources to you via mail, and we'll also post the resources in LinkedIn, so you can take it from there. And thank you for your. Thank you, Aravind.